Yeah, so good afternoon, everyone. We are going to present today the enterprise architecture as and how it enables the digital transformation in different companies and in different domains also. We are going to present today, especially what we are doing in the digital architecture cluster. So hopefully, how can join us for the presentation, because we have very important aspect on how we validate the different models that we can create by using our enterprise architecture models. So we have this content for today. We are going to present something related to the digital transformation, how we see the digital transformation and how it can be challenged, or how it challenged the transformation in the different companies, why enterprise architecture is needed, and then how we use the different enterprise architecture models to support this digital transformation. We are talking specifically about the Archimate language with an application in the smart city domain, and how also we integrate these models with formal methods. So we see that the enterprises find ways to innovate with new technologies by designing strategies for digital transformation that improve the operational performance. So when we are talking about these changes in the enterprises, so for example, we are going to include a new product, a new solution by using, for example, a new technology such as AI, or for example, smart manufacturing, or even if you have a new 3D printer, for example, in your organization. So the impact and the disruption that this kind of new technologies can produce in the companies are seen in the overall company. So we are talking about how it can affect the strategies, how it affects, for example, the organization structure, so how we can include more people. So we need to hire more people with the required skills for this transformation that we are doing in the enterprise. Or we need, for example, a new channel between of communication between the different or the existing line of businesses within the organization. We also talking about the impact on the information systems. So we can, for example, change the way as we can see the data, which is one of the main topics nowadays, how we analyze the data by using, for example, AI, which is more centralized, as I said, on the data rather than on the, for example, services that we saw before. And also what systems are affected by these new technologies, the technologies itself in terms of the infrastructure that support the different technologies, or include the different, for example, sensors in the company, how we deploy them, where they are deployed. And the people that can be seen as customers normally, as the clients, as the patients, for example, it depends on the context, but also the internal stakeholders in the company, in a hospital. What are the requirements of those of those people that we need to be considered? So we can see that nowadays we are talking a lot, for example, about the smart manufacturing, how we implement new AI solutions, but these are not new technologies that appear just in the last few years. So they have been for many years. And now what we have is that thanks to the evolution, for example, of the storage and processing of the devices, we have the capability to process and to process the data, and also to make the reality what we planned before with these different technologies. We have massive data generation, we have a decentralized production, for example, as I said, by using a 3D printer, so we don't depend on a specific service provider. We can have inside of our company, and normally it changes as we are not, for example, outsourcing the services. We change the way that our business processes work. And we have now the integration of value chains, also the decentralization of the decisions, because this is not something that just one person in a department has to take care. So we need to communicate between the different people who is involved in the use of these different technologies and in the use of the data that affect directly the decisions that we make in the company. So just to give you some examples of how what is happening in the company. So how we see a simple transformation within the company with existing technologies that we have. For example, a survey revealed that 50% of the businesses surveyed had experienced an IT project failure within the previous 12 months. So now not much has changed. So in the last year, you can see some examples in the link that I provide you here in the presentation. The number has increased. So 50% of the 126 IT professionals reported that they had a project fail. So we have here a short example of one of these companies. And what we saw is that if you go to the details of this report, you can see that the business sometimes require, for example, to implement new solutions. Just think about a new enterprise resource planning system. And you need to analyze, or in this case, this organization has to analyze. So we need to define or to scope in a different way the business processes that we have, to adapt the business processes to the solution, to the software solution, or we need this to adapt the software solution to adapt directly to the processes that we have, or we need something in the middle. So what, for example, in this case, this company did was keep their business processes. It was the solution that or the decision that they made, but they lost a lot of money because finally the system didn't allow them to achieve their main objective. So there were many stakeholders which were behind of these requirements, and there was like a failure of this company to implement the solution. So now, what are the common causes of these failures in the company? So the main ones are highlighted in the right side of this presentation. You can see that the lack of common goals and a vision, the lack of planning, but also the lack of an architecture and design. Because how we can plan the change, or how we can see what elements are affected when we are changing something in our software, and how it's affected the processes, and finally how it's affecting the different stakeholders. So what the requirements issues, what are the stakeholder engagement, the leadership and governance, and the risk management are kind of common causes. So now what we are saying, or what we in our research group we are doing, is that enterprise architecture can help us to manage the new challenges and to face these new challenges. So for example, in the left side, you can see that we can have a current state of any organization. So when we are talking about this enterprise architecture concept, is that the enterprise must control and plan the constant change, but also the architecture allow us to plan this transformation in a coherent way. So we have, for example, our business architecture, our information architecture, that can be part of the data and application architecture and the technology architecture. So all of these elements are not isolated elements. They are linked, they should be aligned, and they should represent what is the current state of the company. But also we have that the digital transformation or these new challenges, we need to address the future state, for example, and based on new solutions, based on sustainability challenges, based, for example, on new requirements. So we have new, say, standards, new processes that have been changed based on the pandemic that we are living nowadays, but also regulatory standards. So, for example, if we are talking about a retail, what the retail has, for example, to comply with new regulations, or say, for example, particularly with the payment card industry standard, or say any company has to comply with the GDPR. So these elements are important and are making or producing a new state where the company has to move. So by doing this, by using enterprise architecture, we can analyze the current and future state, but also doing the gap analysis to understand what are the gaps at the different levels, what are the list of solutions that we have, and how we can prioritize these initiatives. So finally, having a roadmap, a plan where the whole enterprise can move. So then we have that based on those, if I go back just for a second, to the current and future state, we can represent all these elements that we see in this slide, the business architecture, etc., all these different architecture domains by using models. And Archimate is one of these modeling languages that allow us to model the overall organization. So as we can see here, if we have an IoT integration strategy, it's affecting not just one component of the company at the technology level, for example, of the application level. We are affecting all the different elements or components of our organizations. So we are affecting the strategy, for example, the business models, such as business processes, even financial models, applications, the physical elements that are deployed in an organization, but also the implementation and migration components. So this is the general framework or the general structure of the language, which considers different elements, and which, as we can see in the right side, is using different layers and aspects that can be taken into account when we are assessing or evaluating a transformation in a company. So one of the domains of applications that we did last year, in the last years, is the smart city domain. So we use the Archimate language to extend the language by using the specific elements of the smart city. So we created this extension and we call it Archi Smart City, and we added new elements, for example, new domains, new ways to see the strategies, new ways to measure the smart city performance, to see the different city services that can be deployed in the city, but also the quality of the services and the decision-making support. Because finally, all of these different components are affecting the way that we are making the decisions in the company. And I think that Hao is here. Yeah. So Hao,
Yeah. So
yeah, go ahead, Hao, please.
So yeah. So now the big question is how we can actually to guarantee to make sure the models the actual you build, say for example the smart cities in Archimate is actually correct. Okay. So in order to do that, so what we do or what we propose is we integrate the modeling with the formal methods. Okay, so what actually happen is how we actually do it is say for example on the left hand side is so the input usually is a model, then plus possibly a set of different kind of like constraints to describe what kind of the instance of the model can be produced or can be generated. Okay. Then what we're going to do is we have a translation process, which we will cast the model into a set of different like formulas or mathematical formulas. Okay, then we actually mathematically prove the model is correct. Okay, so by proof is we don't mean we actually prove this manually. Okay, so Viviana, if you can do the slide. Yeah, so what we mean is we actually maybe the previous slide, not this one.
Okay, sorry. Yeah.
So what we mean by proof is, well, of course you can manually prove, but we highly do not recommend it because it's almost impossible. With a smaller model, it is possible, but with a large complex, especially with different type of constraints, for example, you could have numerical constraints, or you could have a larger constraint, then it's almost impossible to prove manually. So what we introduce a machine provable strategy. So what happened is we will use a set of different decision procedure. Essentially, it's a set of different algorithms. So those algorithms can, so the input to those algorithms is actually the set of formulas. So we will so the algorithm will determine whether those formulas are actually provable or not. If the set of the formula is actually provable, that simply means your model is fine against your requirements. If the formula is unprovable or proved there's something wrong in your formula, that we will map the actual back to your model to pinpoint where actually went wrong in your model, so the user can actually fix the model, fix the inconsistency in the model. Okay. So if we, yeah, Viviana, yes, that's great. So what happened is, as you can see, the strategy we use here is we use a set of the algorithm. So the algorithm you can consider as like a math machine. So basically you can operate those machine, you can operate those different kind of algorithm or procedures. So the application is actually, the domains is quite a lot. Okay, say for example, we could to apply those strategy into the cybersecurity. So everybody knows what recently happened to the HSE, which we could model. We could model the certain parts of the website or the network, and then we prove them mathematically. And we could also use in the cyber physical system. So now the cyber physical system is quite it's quite widely used in many areas. So you can think about an example. Say you take an airplane. The airplane is not the actual pilot is flying the airplane. It's actually the computer program is flying the airplane. Okay, but what really happens? You want to make sure the computer programs behave exactly what engineers expect to do. You don't want anything major catastrophe to be happen. So what happened is we will prove them at mathematically prove the actual the algorithm indeed it works. Okay, another example would be autonomous vehicles. Okay, and also in NASA they are developing the next generation space craft. So in NASA they actually also use the formal methods to prove the safety properties of their future spacecraft. Okay, so yeah, that's great. So what I'm going to focus on here is focus on the cybersecurity issue, because everybody know what happened to the HSE, and seems to they still couldn't fix their website. Okay. Now, what we could do here, what we could propose is we could there's two levels. One is high level, one is low level. So speak of the high level is what we call it model verification. So basically, we want to uncover the actual the design flows. Okay, there's definitely going to be a lot of design flaws in the software models. But in the low level is actually dealing with the source code, what we call the static verification. Okay, but when we focus here is we focus on the high level. So therefore, that will lead us give us different possible proposals here. Okay, so I listed 4 different proposals. One is the security policy. There could be something wrong in our security policy, because when you're making the policy, it's not that easy. The policy consists of a set of different requirements, or maybe different constraints. Maybe there's some conflicts in the security policy. So therefore, by using the strategy, the paradigm we described in the previous slide, we could uncover the certain conflicts in the security policy. Okay, similar to the model components, we could break down the model into different smaller components, and then we formally verify to prove whether there's any, say, communication errors, or there's any causing unsatisfied constraints could happen in those model components. Okay, the third thing is the data flow graph. So essentially, is a graph. So we have with directions. So we could also possibly derive mathematically model this data flow graph and then prove the actual, or maybe to optimize the data flow process. Okay, then the last one is involved with when you're upgrading your system. Okay, we say, for example, you install a new package or install a new patch onto your existing operating system or into existing your system. So what happens is those packages or those patch usually come up a lot with dependencies. So it doesn't mean you can easily install those patch. It depends on what actually has been already installed in your existing system. Okay, so sometimes those dependencies will cause a fatal errors, will cause system crash. So therefore, what happened here is we could model those dependency graph as like a tree model, and then we verify whether, say for example, when I install the patch A, I cannot install patch B. So when I install patch B, I cannot install patch A and patch C at the same time. So we'll be able to remove those ambiguities or to resolve, so we called dependency health problems in the high level here. Okay.
Yeah, so that's our talk for today. We are, as we said, a part of the Enterprise Modeling Research Group. First, we have Professor Marcus Helfer from the IBI. We have Joseph Timony from the Computer Science School. And we have also Hao, who is the associate professor at the School of the Computer School, and I, as a postdoctoral researcher in the Innovation Value Institute. So we are happy to answer any of the questions that you probably have.
Viviana, can I ask a question?
Yeah.
So does something like this become more important, the more formal verification as architectures move to more microservices type architectures rather than, I guess, more monolithic traditional approaches? Would this help in terms of the modeling of those and understanding of the interrelationships and complexity of microservices type approach?
Yes, so thanks, Paul, for the question. So when we see like the new approaches for designing the architecture of the different systems now that they are using these microservices. So finally, what we are increasing now is also the complexity in the architecture, although at the end, on the systems, what we are doing is trying to manage the complexity. For example, we are with the microservices, we have like different, for example, databases. So for each service that we are creating, we have a specific database, for example. So it depends how many databases we have, how many microservices we have, so how many instantiations for the database we have also. So with the enterprise architecture approach, what we are telling you is from a high level of the organization. If the microservice architecture, for example, is required, and why is required first? So how it supports the different processes. So it's required to do the microservices in that way. And then, as you said, the different connections between the different data components that we need to take into account when we are doing finally, or we are presenting finally the end system, which is using the different microservices. But one change in the architecture, that's why enterprise architecture helps us to do is when we are changing a specific component in the architecture, say a specific microservice, for example, how it affects the rest of the architecture without causing any disruption on the existing system. Yeah. So the enterprise architecture can help us to manage these complexities, even when we are using these microservices.
Thanks, Vivian.
Thanks, Paul.
So maybe I can also ask a question, and it's like your opinion, Viviana, or how on this. So, like it seems to be, in particular, I think the last 12 months or a bit more with the COVID crisis, kind of the speed, flexibility, the changes, all of this actually, like it's amazing how fast things have changed and can change. So that whole agile flexibility and all this seems to be quite important also to adjust to new situations and all this. Wouldn't you see then architecture as a kind of a constraint or a restriction of actually that speed and change? So that actually it's kind of really a big trade-off between on the one side having architecture, on the other side having really agility, speed, flexibility. How would you see that? Is architecture still then really relevant in that kind of thing, or how does that trade-off actually happens, or is it not a trade-off?
How do you want to answer? Do you want to?
Yeah, I think architecture is certainly like important because well, if you say because if you develop a software, like it's obviously it's one of the most important software development cycle. So when you say the architecture, so what happened is so we don't want to like something well, from my point of view is we don't want something obviously like go wrong at the top level. So therefore we need to, so basically you can think about this in like a first line defense of uncovering any design flaws, and then you could have other like micro tools or services to uncover at lower level. So I don't think well the trade-off is obviously is if your model is getting really like a complex, okay, so like maybe have multiple different layers, then this could cause maybe like a scalability the problem. But I think this problem is a general problem actually in the current software engineering. So if you look at any like a software engineering subdomains, they actually dealing with, not even software engineering, in computer science, if you look at all the subdomains, they actually dealing with those challenges. But there's actually quite a lot of different approaches or techniques to resolve this kind of thing. But I still think there's quite a lot like work to be done to ensure the correctness of the architecture model.
Yeah, thanks. Just to add something is that how we can use the agile enterprise architecture or the agile approaches to make the architecture, to create the architecture also, so we can prioritize what is more important, for example, to produce the value for the companies or to solve the current problems. But when we are talking about the agile approach, we sometimes forget what is really important. For example, the cybersecurity is one of the requirements that we cannot manage at the end of the project or what at the end of everything. So the cybersecurity should be, even if, for example, in this kind of agile problems or solutions, be one of the key requirements that should be addressed all the time, and maybe first as with other critical processes and components of any organization. So we can do the agile part, for example, to give the value to the company, to the stakeholders, but we need to also focus on what is really critical and important by doing the prioritization of the solution, and that's where enterprise architecture can still help us for doing that.
Thanks for the answer.
Just to finalize the presentation, so as you know, the IBI institution is doing the different webinars, etc. So we have some information that you already maybe have in your email. So we have the Perform European Digital Retail Summit that we want to also promote here, and for the next June 18. And we have also, as you know, very important information that we are sharing, or the IBI is sharing. So please share the information also with the people that you know that could be also interested in the morning newsletters. We have the LinkedIn site, we have the Twitter, so we are trying to be active as much as we can. So please visit our online resources. So I think that is all for today. Great.
Thanks, Viviana. Thanks, Hao. That was a really great session. Thanks, everyone. We'll see you next week for the next Coffee Talk.